Gentlemen, welcome back to the shop. Today we are going to make a very simple hardness tester out of a ruler. Now, fast approaching is the time of year wherein that fat man comes down the chimney and engages in a mandatory exchange of Star Wars branded merchandise. As my dear, sweet, loving, and long-suffering wife would tell you, partly due to my procrastination, I'm not gonna hit the window here for Christmas on this little device. But here's the idea. These hardness file testers, friggin' awesome, but they are rather expensive. For hardness testing, that is the cheapest option to date. There's also more expensive options, about $1,000 You can get a Rockwell hardness tester that's just portable, and it indents a material, and you look at it through a microscope and you see how big that indent is. That tells you the hardness. Also, you could get a Rockwell tester, which is going to run you 5, 10. Okay, you primed? You stoked? Get to the fucking point, this guy with the blathering on. 3 components. We need a scale. We need, well, here we have the Alpha Azar platinum wire. And I was going to make a lighter out of this platinum wire, but that old brainiac, applied science, beat me to it. So what we're actually going to do is just use the tube. Now we hoik the detritus off of one edge of the scale, let's go metrique. We'll kowtow to those continental types today. I'm feeling generous. And then we just apply a wee bit of glue, what for making a proper bricolage, and then stick that to this, and we wait. And here we go, bunch of different materials, brass, and you gotta stick it in the hole. That's what she said. Hey-oh, 5.5 centimeters. So 5.5 sims, 55 millimeters. 6.5 on the aluminum. 8 on the mild steel 44W. Here's a forklift tine. This is high carbon steel. Whoa! Off the scale. It works. It's working. That there is pretty damn cool. So this is an old chopped up forklift tine. We're gonna start with the Rockwell C test blocks, the Rockwell hardness standards here. And, ooh, shiny. Get that on there like that. Yeah. Give this a try. So we're at 33.2. Pleased as punch if this is working. Now this is gonna be hard as a coffin nail here. 61. Here's the trick of it though. You won't be able to make the delineations for what hardness it is, because you need these standards. And these standards, I think, are 60 or 70 bucks a piece, so not fucking cheap. But I have also, the other thing is, you're relying on your visual acuity and also the quality of the lighting in the shop and so forth. Obviously with the high-speed camera we can get her dead nuts on, but watching a little ball bounce up and down, that's a little bit tricky, right? You're gonna have to do it a few times to get a pretty accurate reading. 62 Rockwell. I'm pretty chuffed at this. You'll forgive me if I can't get my hat on here. I'm a vain and petty man. That fucking idea worked. Incredible. But here's the thing. You're relying on your visual acuity. And, of course, you need the standards in order to make this. You need a known sample to be able to delineate this at certain hardnesses. What about? Okay, so that fucking an evening's worth of bumblefuckery, that ain't the bag, partner. But, idea. We put a little microphone on here and we listen for the taps. First tap, we count how long it takes until the second tap. We correlate that to a hardness. Now we're not relying on anybody's visual acuity, there'll be a little display that'll tell you in digital format how many Rockwell it is according to how long it took from the first click to the second click. Huh? Now, I sat there thinking about this, and I do most of my thinking in my head, the nautical kind. You can probably hear my beanie propeller just a whizzing. Now, the thing is about this, if the sample size is, if the mass of the sample is too small, it is going to throw off the reading. So we need to do a little bit of a study to ensure that this little BB rebounds properly, and we want the mass of this BB to be as disparate from the mass of the sample as possible. We want it to be as big a difference as possible, but at some point there will be a cutoff where it won't be accurate anymore because the two masses are too close together. Now, I've been kicking around ideas with the Ingenuiting team. Not to worry, we keep those guys off site from the Empire Dirt, especially the electrical guys that tend to migrate toward warmer climes anyway. I mean, we got some more ideas on this. Now, hold on here, patent trolls, on this public disclosure of a novel invention. What we're going to do, what we're going to try, is putting a piezo element on the backside of a ruler, have a whole bunch of electronics on here, and that way we're not worried about the microphone getting noise from other places. We'll just be monitoring a pressure spike in the material itself, or a sonic wave in the material itself. As the ball drops, it'll count up, and then when the ball hits again, it'll stop. It'll correlate that to the Rockwell C scale, or whatever scale you want. We could go whatever. This could work for shore hardness on plastics. You could have a little button and it says for sure. I mean, fuck, this is some citizen science going on here. Your considered discourse, your considered comments is very much appreciated. And of course, if you know of any prior art, Cunningham's Law being what it is, I will say there is no prior art. However, the internet's smarter than just some bumblefuck in his garage. So if you know of any prior art, or you have a better idea, please, down below me in the doobly-doo. Thanks a lot for watching. Keep your dick in a vice.